Okay, so let's talk about energy. It's literally everywhere, from the kettle boiling for your morning coffee to your phone lighting up. The whole universe basically runs on one simple rule. Energy is always on the move. And while that might sound super complicated, it all boils down to just a few core ideas that we're going to unpack right now.
But have you ever stopped to think about how that actually happens? How does the energy from the socket in your wall get into the water to make it boil? How does it get from a battery into the sound that's coming out of a speaker? That's the big question, and that's exactly what we're going to get to the bottom of in this explainer.
So, here's our game plan. First, we're going to cover the absolute basics of how energy gets around. Then, we'll dive deep into the 4 specific ways it happens. Now, the key to all of this, and I mean this is the real secret sauce, is knowing the difference between an energy store and an energy transfer. We'll see it all in action, and then I'll give you a heads up on some common mistakes to watch out for. All right, let's get right into it. The single most important thing to realize about energy transfers is that it's not as complex as you might think. You don't need to memorize a million different rules. In fact, pretty much every single energy situation you can imagine can be explained with just one simple number.
And that number is 4. Seriously, that's it. It all comes down to just 4 fundamental ways that energy moves from point A to point B. If you can get your head around these 4 pathways, you've pretty much mastered the entire topic.
And here they are. Energy can be transferred mechanically, electrically, by heating, or by waves. That's the complete toolkit. These are the only 4 options you'll ever need. So let's break down what each of them actually means.
Okay, so let's take a closer look at each of these 4 pathways. Think of them as the 4 main highways for energy. We'll start with the one that's probably the most obvious. First up, we've got mechanical transfer. This is the physical one, the one you can see and feel. It happens anytime a force makes something move. The 2 magic words here are force and movement. If you have both, you've got a mechanical transfer. For example, pushing a shopping cart, you're applying a force, and it moves. Lifting a weight, you're applying a force, it moves. Even when the brakes on a bike slow it down, that friction force is doing work. It's all mechanical. Number 2 is electrical transfer. This is the one that powers our world. It's all about tiny moving charges, what we call an electric current, carrying energy through wires. Anytime you plug something in or use a battery, this is the transfer that's at play. Our third pathway is heating. This one feels pretty intuitive, right? It's just energy on the move from somewhere hot to somewhere cold. But what's super interesting here is that this one process can actually happen in 3 totally different ways. And this table breaks it down perfectly. In solids, you've got conduction, where particles vibrate and just bump into their neighbors, passing the energy along like a game of dominoes. In liquids and gases, you get convection. The warmer stuff expands, gets less dense, and rises, while the cooler, denser stuff sinks. It creates this circulating current. And then you have radiation. This one's special. It uses infrared waves, and this is the crucial part. It doesn't need any particles at all. It's how the sun's heat gets to us through the empty vacuum of space.
And that's a perfect lead-in to our final pathway, waves. We're talking light, sound, even the ripples on a lake. In all these cases, waves are carrying energy from one place to another. But here's the key thing to remember. The wave moves the energy, but the stuff it's traveling through, the matter, doesn't really go anywhere. The water in the pond just bobs up and down. Okay, so now we have our 4 pathways. But to really, truly get this stuff, there's one more skill you have to master. And that's telling the difference between an energy store and an energy transfer. This is a total game changer.
Check this out. A store is where energy is. It's a place where energy is just sitting. Think of it like a noun. You have a kinetic store of energy or a chemical store. A transfer, on the other hand, is how energy moves. It's an action, a verb, like heating. It's the difference between having money in your bank account, the store, and spending it, the transfer.
Let's circle back to our kettle. Energy is transferred electrically from the wall. That's the action, the transfer. And where does it go? It increases the thermal store of the water. That's its destination. See? Transfer versus store. If you can nail this difference, you're golden.
All right, we've got the theory down. We know the master skill. So now let's put it all together and look at a couple of real-world examples. Time to see if we can walk the walk.
So, here's our first test. A light bulb. You flick a switch, it turns on. We do it every day. But before I show you the answer, take a second. Can you identify the transfers and the stores involved here?
Let's trace the journey.
First, energy is transferred electrically along the wires to that tiny little filament inside the bulb. This energy gets dumped into the filament's thermal store, making it get super, super hot. And because it's so hot, that energy is then transferred away from the filament by waves, specifically visible light waves, which we see, and infrared radiation, which we feel as heat.
Okay, let's kick it up a notch. Example 2. Someone is pushing a box, but this time the floor is rough, so we've got friction to deal with. This has a few more steps. What's the complete energy story here?
Okay, follow the energy. It starts inside the person, in the chemical store of their muscles. As they push, that energy is transferred mechanically to the box. The box starts moving, so its kinetic store increases. But that's not the whole story. Because of the friction, that mechanical work is also transferring energy to the thermal stores of both the box and the floor, making them both get a little bit warmer.
Okay, to wrap things up, let's quickly talk about one of the most common mistakes people make. Knowing this little secret will give you a massive advantage and help you avoid some easy-to-lose marks.
This right here is probably the biggest misconception in all of physics. You hear it constantly, right? The energy was lost to heat. But if you say that in a physics context, it's a huge red flag. It's just not true.
Because here's the absolute, unbreakable law of the universe. Energy can never be created or destroyed. It can't just vanish. It doesn't get lost. What actually happens is it gets transferred into a less useful store. Usually it spreads out as heat into the surroundings. So remember, energy isn't lost, it just becomes dissipated.
So there you have it. 4 simple pathways that explain basically every energy interaction happening around you. So my final thought for you is this. Just look around you, right now. The light from your screen, the sound you're hearing, maybe the warmth from your device. Which of the 4 transfers can you spot in action? Once you start looking, you'll see them everywhere.